Hi guys, today I'm going to teach you how to do some simple mole calculations, hopefully give you all the skills you'll need to do this in an exam. One important skill before you move on to mole calculations though is to calculate the relative formula mass, and that's what we're going to do as a starter now. If you can't do this after this example, you're going to need to go back, have a look at some other videos on how to do this. So you will need a periodic table, and if you look at periodic table, you'll see that hydrogen has an atomic mass of 1 and oxygen of 16. But we're not done there yet. What we need to do is look at the formula and you'll see that you've got two hydrogens. Okay, so that means 2 times 1, which is 2. So you need to take into account this little number here that tells you've got two of these hydrogens. There isn't any little number at the end of oxygen, so that means we've only got one. So oxygen, we've only got one of. So that must just be 16. Once you've done that and you've got the masses for the elements involved, add them together. So that's 16 plus 2 gives us overall relative formula mass of 18. Okay, so what is an actual mole? Well, a mole is a chemical term for an amount of substance that contains exactly 6.02 times 10 to the 23 particles. Now we call that number Avogadro's constant. And it just means that if you had 1 mole of any substance, it would always contain that number of particles. And as you can see, it's a very large number. So chemists like to think of these things in terms of moles because it makes it easier and more manageable to think about. You're not going to have to define moles. You're more likely to be asked how to calculate them. So that's what we're going to focus on in this video today. And to do that, you'll need to know this little key piece of information. If you have 1 mole of water, it's equal to its MR in grams, its relative formula mass in grams. We've just calculated that. So this should be pretty straightforward. 1 mole of water we'll know to be 18 grams. 2 hydrogens, 1 oxygen, remember? 2 plus 16. And if you have, carbon dioxide, you can do the same again. How many grams would be in 1 mole of carbon dioxide? Well, carbon is 12, oxygen 16, and we've got 2 of them. So if we do that calculation, 16 times 2 is 32. 32 plus 12, well, that works out at 44. So we'd have 44 grams of carbon dioxide in 1 mole. Right, there's an extension at the bottom there for you to have a go at for iron oxide. I suggest you pause the video, get yourself a periodic table and have a go, and I'll reveal the answer afterwards. Right, so 2 irons, 3 oxygens, that should come out at 160. 56 for each of the irons and 16 for each of the oxygens. Let's have a go at the next one. So, this is probably the most important thing you will need. This is a calculation triangle, and some of you may have seen these before. But for those that haven't, I'll explain how they work. If you copy this down, and then you cover up whatever you want to know, it will reveal the calculation you need to do. For example, if I want to know what my mass is, then I cover it up and it's MR times moles. If I want to know what my moles is and cover up moles, it would be mass divided by MR. Simple. So let's see this in action. How many moles in 100 grams of H2SO4? So the question's asking for moles, so I need to cover up this one here and reveal the calculation, mass divided by MR. Well, we've got the mass, it says it's 100 grams. We just need to calculate the MR of H2SO4 of this here. Now that might take you some time because there's lots of elements in here. There's hydrogen, sulfur and oxygen. Hydrogen's 1, sulfur's 32 and oxygen's 16. If you add all those up together, you get an MR of 98. So once you've got the mass and the MR, it's just a case of plugging them in to a calculation. So moles equals mass divided by MR. So mass, 100 divided by MR, 98, and we get 1.02. We're going to do some together. We're going to do one more worked example, and then I'll give you some to have a go at. So how many moles are in the following? So what are we presented with here? Well, we've got a mass and we've got an element. Now, if you've ever seen element or a compound, that's probably going to mean that you're going to have to do the molar mass. So we're going to have to work this out. If you look at a periodic table, you'll see that that's 23. You've already got the mass, so now we just need to look up here and see what we need to do with these numbers. Well, we're after moles, so that's going to be mass divided by molar mass. So mass is 100 grams divided by the molar mass, which we know is 23. Get your calculator out. And that comes out at 4.3. Simple. Here's some for you to have a go at, and then I'll stop and reveal the answers again, okay? Right, so let's have a look at the first one, 1A. Well, all of these are asking for the number of moles, so it's always the same calculation. It's always going to be mass divided by molar mass. So the mass is 90, and we're going to divide that by the molar mass, which we'll need to work out for each of these examples. The molar mass of water is 18, so 90 divided by 18 is 5. This one, the mass is 20 grams, divided by this, very complicated, or it looks to be. It's not if you just break it down. So if we do this for butane, which is this compound here, C4H10, what we'll see is we've got 4 times 12, and then added to the 10, we've got for the hydrogens, 1 for each hydrogen. You'll see it's 58. So 20 divided by 58 works out at 0.3. Finally, you've got this one here, ammonia. So if we take the mass, 685, divided by the MR of this compound here, nitrogen equals 14, and you've got 1 for each of the hydrogens, so 14, 15, 16, 17. So 685 divided by 17, that comes out at 40. Right, now what we're going to do is we're going to do a new set of examples, but this time you're asked to calculate mass. Now, it's the same sort of principle. You just need to use your calculation triangle up here, cover up the thing that you want, which is in this case mass, and it reveals the calculation that you need to do, moles times molar mass. So mass equals moles times MR. Okay, so pause the video, have a go using that calculation, and then we'll reveal the answers. Right, so for this one here, you've been given the moles, which is 4. So mass equals 4 times the MR. Now the MR, you've got a little 2 here, so don't forget about that. It would be 14 times 2, which is 28. So 4 times 28, and that is 112. For this one here, the same again, you've been given the moles. So it's 0.100 times the MR of this whole compound here. Remember, hydrogen equals 1, nitrogen equals 14, and oxygen equals 16. So you've got 1 added to 14, and then here you've got 3 16s. So 16 times 3 plus 1 plus 14, that gives you an overall MR of this one of 63. Now if you do 63 times your moles, you get 6.3. So that's the answer to that one. The final one down here, to work out potassium, so K is 39, oxygen equals 16. So the mass would be your moles, which is this one here, 0.0200 times the MR. So let's work out the MR. Remember, you've got 2 potassiums, so 39 times 2 plus your 16 for your oxygen gives you a total of 94. Times that by your moles, that gives us 1.88. So as you can see, It's not particularly difficult as long as you're using that calculation triangle to find the correct calculation to do. Now there is one more thing it could ask us. It could ask us to work out the molar mass of something. So I'm just quickly going to erase all the pen on here and we're going to have a go at doing this last one. So here we've been given the moles of a compound is found to have a mass of 1.64 grams. Find the formula mass of the compound. So again, what do we need? We've been asked to find the formula mass. So go back up to your triangle here. Formula mass is the same as molar mass, so cover that one up. So to do the calculation is mass divided by moles. So MR equals mass divided by moles. Pause the video, have a go at this one, then again we'll reveal the answers. Right, so for this last one here, we're going to have a look. So the MR of this particular compound, this one known, we know the mass is 1.64 grams, and we're going to divide that by the amount of moles, which is 0.0200. So if you do that in your calculator, you get an MR of 82. Okay, simple. So these are the 3 simple mole calculations that you could be asked to do. You could be asked to do any 3 of them, but if you remember just the one calculation triangle, you'll be able to do them all. Okay guys, and that's all there is to it. Hope it's been helpful. I'm going to leave you with 4 questions to have a go at. See you next lesson.